Okay, so welcome, folks. We are going to be presented on EDW automation in Synapse. So just check, get you in the right room. If you're looking at sort of Databricks, no, that's not this room. um, for those of you who don't know me, my name is Bob. I've been around the database sector a long time. I'm what used to be called a SQL Ranger, or a certified architect on the SQL platform, MVP and all that stuff. I guess the important thing for this talk is my day job is I work as a principal architect for a partner that helps customers implement enterprise data warehouses on the Microsoft platform. And that takes a range of, we have SQL dedicated pools, we have SQL in VMs, we have SQL on-premise, we have SQL DBs, and we design kind of data warehouses and all of them. And this talk comes from my experience of managing my teams in how can we do things better. I also spend a fraction of my time doing reviews on customer sites where the customer has implemented it and it's gone a bit pear-shaped. It's very slow for them to implement, it's very costly for them to implement, or it's performing like a dog, right? And I'll go in as an external consultant to do like a review and help them get an action plan. So that's really where this talk sort of comes from, is my experience on that, right? So we're going to be going through this. I've got a much longer session I do over a day or two on sort of data warehouse architecture and design principles, but I just want to go through some of the key tenets that I think any database architect should look for, and then most of the session is then a demo of what an automation framework might look like on dedicated SQL pools, okay? So this is what I call universal architecture. Is when you're building a star schema, an enterprise data warehouse is really the ultimate star schema because there's lots of facts and stuff in it. It's always ETL as far as I'm concerned. Extract, transform, and load are the logical phases. It doesn't matter what technology you're using, whether you're a SQL DB, a SQL Server, Databricks, SSIS, ADF, you're always going to have an extract phase, a transform phase, and a load phase. The bits that are dotted lines is it could be virtual. So you might do staging, but you might use something like sort of polybase, so it's not physically staged, but it's still a process of staging, right? And the hard bit is where the bit in the magic happens, right? Everything else is quite easy, actually, right? So one of the frustrating things is when I talk to other people about automation, they're harping on about the easy bits, right? The extract or the ingest, right? For me, that's where my developers spend their time, and that's where I want to be automating, right? So don't tell me that you're an expert in automation if you've automated staging, right? So the magic. So what is the magic? That's where you build your star schema, you cleanse, conform, integrate. There's all of your activity goes on in that, right? And the load phase is quite deterministic. How do you load your star schema once you've got your curated set of data? So if you're a SQL-centric architecture, your staging is going to be in a schema within your dedicated SQL pool, and your transforms are going to be based in the SQL pool. Views, stored procedures, stuff like that, okay? And your end target is going to be a schema in the SQL pool as well. If you're using an ETL tool like ADF or SSIS, God forbid you use SSIS on a SQL pool, it would look like this. So you might take your staging direct off the lake and go through a pipeline type process, and the transform could be in the pipeline. I know Microsoft do have some templates in sort of data flows. I wouldn't use them. I wouldn't terribly recommend them, right? But it can be done, right? Or if you're one of the cool new kids, you might be doing it completely in sort of data lake and be doing your transforms in Python and notebooks. It's still ETL as far as I'm concerned, because there's an extract phase, there's a transform phase, and your final thing is to load into your final curated star schema. And there's a hybrid model, is where one of them is centric and one of them is child, but you're kind of hedging your bets because you're like, I'm going to use my SQL to transform all my data, but my star schema, I'm also going to present on a data lake, or the other way around, right? So what we're about is, how do we do this efficiently? So the first thing is to talk about, these are architecture and design principles, right? So when you buy your platform, the architecture is what components do I use? And here's a list of principles that people look for when they pick their architecture, right? Now, and then on the right side is what I call design principles. So the left side is what you're going to do, and the right side is how do I do it, right? And for me, that's the difference between architecture and design. Now, the bits in red are my favorite ones. And the misconception is vendors will convince you that you buy the things in red, right? You buy performance, you buy scalability, you buy extensibility. Absolutely not, right? You design these. Now, the platform will give you your maximum scalability, but when I go in to do a design review, the performance our customers are getting could be 100,000 times worse than what the benchmark was. So whatever the benchmark was is irrelevant to the performance that they're getting. It's how did they design it, right? So the focus on your load of your EDW should be, I did a survey on that sort of Twitter, and the number one thing that came back, agility, right? Data warehouse architects want agility. And my next favorite is probably extensibility, but a few people said a few other factors after that. So just before we go into a demo, what is agility, right? And how do you measure it, right? So agility for me is how fast can we add a dimension or a fact into the conformed star schema, right? And when I go to a customer, the first thing I ask is, how long, right? I'm waiting to see, do I get hours, days, weeks, months, or quarters, right? And that gives me a sense as to how agile they are, right? Now, the other thing is I check by, I say, how do you do it? And if I get answers back, like, well, as soon as I build a dimension, I assign a developer to start writing code, I'm immediately, these guys are not agile, right? It's going to take a lot of time. So warning signs are any hard-coded work that has to be done in terms of writing code, low-code GUIs, or anything like that that has to be done by a developer and go through an SDLC and a release process, it's going to slow you down. So you're looking for metadata-driven processes, no schema binding and duplicate schemas throughout the sort of process to make it more agile. So I score what I call design efficiency, which is a variant on the architectural principles of DRY that everyone knows. Design efficiency is how many times has your developer repeated the schema content so it has to be changed, right? Imagine he's written a pipeline specifically for that. 1, he's created a table in staging. 2, he's put a view over that and hard-coded a select statement. 3, he's written a stored proc on top of that and written 4 update statements to sort of scrub it. 5, 6, 7, 8, 9, 10, right? So it's 10 times less agile than it could be, right? So the ultimate goal is a score of 0, right? I just drop a file in and it magically appears, right? Now, obviously, that's almost impossible. But a score of 1, a score of 2, a score of 3, can I get only 3 tiny touches that don't involve code to get a whole new dimension? And that's what we aim for. Extensibility is, as an architect, I make decisions at the start of the project. And one thing I've realized in my old age is a month into the project, I realized that 30% of my decisions were wrong because they were based on a lack of knowledge by me, the customer not quite telling me everything, or just I get a better insight because I understand it better. So extensibility is the ability to change your mind and switch the design midway through the project or when the technology stack changes, right? For example, Microsoft have a seesaw between copy into and sort of polybase. They're like, yeah, poly and base is it. And then watching the guides online, suddenly, no, we recommend using copy into. And then 3 months later, I noticed it's changed again. It now says polybase is recommended, right? So you might want to change how you do things. New things, the merge capabilities is out now. Can you switch your entire data warehouse to use merge instead of a multi-step operation when it's released, right? That's extensibility. And the warning sign here is when you mention a change, like, I want to use merge across all my dimensions, and someone's like, oh, man, we're going to have to rewrite the entire stack. That's like a 200-man-day job. That's a sign of low extensibility, right? What you want for extensibility is when someone says, can you use the merge statement? Someone says, yep, I'll have all the dimensions updated in 5 minutes, and it'll be ready for test. That's extensibility, right? And that's what we're aiming for. To get this, you obviously need an automation framework of some sort, and a lot of people have built their own ones that have bits of this, right? So this is what I would call a complete orchestration automation engine. I separate it into 3 components in yellow, green, and blue, right? And at the heart is a metadata. You've got to soft code the peculiarities of the kind of data. So if I'm ingest, what is the container? What is the directory on the blob store? What is the file name? What format it is? Are there any special instructions? You know, if it's a CSV, is it a comma delimiter? What sort of Unicode standard is it in, right? And for load, you can have smart defaults, but you might also say, well, I want an identity column on that. I want to dedupe that table. So you'll have a metadata table which describes the development process, but the code writes itself. So the developer is now only ticking boxes, and patterns of code are being written based on the tick boxes made, so patterns of code can change, right? So kind of metadata is the heart. We have what I call FATs. So FATs, some people call it enterprise features, lineage, login, and error handling. And when I mean lineage in terms of data warehouse, I don't mean schema lineage, like in terms of purview, where did my column come from? I mean row lineage for auditing purposes. I'm looking at an individual row in an individual fact table, and I want to trace back the file that that came from, you know? When we build financial systems, we have to have that level of auditability, right? I can't just say, well, that column came from that source. I've got to find the exact person who loaded it and the exact file to kind of trace it back. If I see a developer writing FAT, I failed, and I either fire the developer because he's not on board, right, or I fire myself because I should have given him a framework where he doesn't even see instrumentation. A developer should not be writing instrumentation. The framework, the platform, does all the instrumentation, right? Then we have what I call pipe. I should probably use a different word, because when I say piping, that people think of pipelines in ADF. I mean, when I say piping, I mean deterministic stuff like copying data, moving data, stuff that a developer shouldn't be writing because it's too easy. You want to automate that as quickly as possible, right? Now, you start off with the easy stuff, like extracting into staging. That's only copying, right? And then you find there's other parts. Loading a dimension is exactly the same for all of the dimensions. Loading fact table. Now, there's variations, right? Am I using pre-staged keys? How am I doing my delta management? But there's not that many variations. So you can define a metadata table that says, well, use this variation or that variation of the design pattern to load. So piping, you want as much of that as possible. And meat is what developers need to work on, right? And this is the semantic model that cannot be automated, right? So you're going to have in your transform something that takes the source data and at least changes its language, cleanses it. If there's a null, it's got a node to copy out the null. You know, those types of transforms we can't really automate because a semantic model is a human applying the business language to the kind of source data. So you want your developers to spend 100% of their time on the meat and none of their time on the fat and the piping. And that's the basis of automation, right? So for a demo, I have AdventureWorks, but not the AdventureWorks that you all know and love. Well, hopefully most people know AdventureWorks from its internet sales and reseller sales, right? Well, inside AdventureWorks is also, I'm not sure I could call it an ERP, but an accounts package in that it's got a chart of accounts and a transactions table and a GL kind of system that will be similar to an ERP structure. So I've taken that, and we've assumed that we've got all these files in a data lake, and we want to build an EDW and build an analytical system on top of that. So in the rest of the talk, I'm going to try and do that from an empty SQL pool, right? So so the first thing is I've got my files in a staging area. Now, everyone knows that I could use Polybase to kind of load them in, and everyone's seen this kind of syntax. There's thousands of demos on it, so I'm not going to demo sort of Polybase working, right? But I'm just going to use it once to create an external table, right? Now, so if you were manually writing code, you could obviously code your E part like this, right? And you see here that runs, and I've got my transactions table loaded, right? I could create a physical staging table by then doing this, a selector into or a CTAS to create from my logical table into my physical table, right? And you might find you get slightly better performance on working with a physical table, which is quite normal. That's basically Polybase. Copy into is very similar. So I run this copy into command, and it's going to suck it out of my data lake, put it in there. So we want to automate that. Obviously, you're going to write dynamic SQL to suck the relevant bits out of the metadata. I can store my container, my directory, all of those blue things are all going to be parameters on your metadata table that you're then going to automate writing that. So when I write that, I end up, our metadata system looks like this, right? We have configuration tables that are the heart of the metadata. So our developers spend all their time in the config tables. They don't actually spend their time in ADF and stuff like that. Even though there are ADF pipelines running, they're not writing the ADF pipelines. The ADF pipelines are only reading the kind of metadata in order to execute, right? So just to show you a SQL pool. So an empty project, if we landed on a customer site, we'd always have these starting tables exactly the same, and we'd then populate them bespoke to the customer, right? So if I just make sure, I'm going to make sure I don't have a star schema, I've got no staging tables. So the first table that we set is a table to store the equivalent of my link services in ADF. What is the name of the data lake, right? So that when I write the TSQL, I can bring it in. We have the concept of a data source where we group text groups of files. I've got this bunch of CSV files that come from the kind of CRM. I've got this bunch of Excel files. It's just a way of grouping the metadata so you can set it, so you set all your properties at a higher abstraction level, so the lower abstraction level doesn't need any detail because it's already defined. You could kind of call it inheritance, I suppose, right? Because the configuration is done at the highest level, and the child then also has that, right? That's my data sources, and then this is the real work. For every file I want to bring in, I just create a row describing it, and I really only need to say, well, where is it coming from, and where's it going to, and a couple of extra properties. I can choose to define the schema or have schemaless, where it'll try and infer the schema. One of the great features I haven't added yet is the copy into now supports schema inference. In the past, we'd have to use the ADF feature to get the kind of schema. And what we'd do is we'd bring that in, and if we want to do tuning, we might tighten the schema to narrow the kind of data types, because staging goes faster when you do that. So there's a choice between agility, which is schemaless, and you take a slight hit on agility to hard code all of the sort of data types for performance. So sometimes we have a tuning phase where we do tighten the schemas a bit, right? So once I have that, I have all my extracts, and I can then effectively automate that. I can write a stored procedure that takes the metadata, and here, shock horror, I've exposed it in Microsoft Access, just as an insult to Management Studio, because they don't support editing rows anymore in a SQL pool. Anyway, you can see here's all my kind of metadata. So it'd be very easy to write code to use this to construct the TSQL to effectively bring it in from staging. So here, I run this just for a dimension, and you'll see it can either do a CTAS or it can manually create the table and then do an insert into, right? And there's actually a bunch of if statements to decide what algorithm it uses based on what it has to do on the kind of settings, right? So here, it's actually manually created and then done a copy into, because it's using a feature to add a column that's not supported by CTAS. So it has to create it first and then insert into. But if it didn't need that, you could write that as a CTAS, right? Now, once you've got your basic, what we call your library function, which is doing all the work, you can then, all of your enterprise features, lineage, login, is hidden into that so that the developers doesn't see that. So we have a log that stores every extract, how long it took, where it came from, where it went to, you know, the performance, the resources, the throughput, and everything else. But the developer's not going to write that code. It's just going to appear when they invoke that stored procedure. And then, before we talk about orchestration, let's just talk about extensibility, right? Changing your mind. So currently, it's using a copy into, right? I speak to some of my friends at Microsoft, and they go, no, copy into was last year. It's polybase this year, right? So I'm, okay. So I change, or I write another stored procedure that does it by using polybase. So the copy stored procedure is here. I put a flag on my metadata table that says, hey, do you want to use polybase or copy into? So this is one that's building dynamic SQL by using the copy. I write one that does it by using the polybase, and then the parent stored procedure has a case or an if statement saying, depending on what you've picked, or depending on what the default is, I could change the sort of default. I'm now going to do a polybase, right? So here's all the polybase code is here. Is this polybase? Yeah. No, that's the copy into code. Whoops. Polybase, if you're building a dynamic polybase code, it would look like this. So drop external table, create an external table. And if you use ADF and tick the sort of polybase option, this is basically the code that it builds, right? So when I go to here, I can update my metadata at the data source level and say all of my files within this switch to use polybase. And now my extract is no longer going to use a copy into, it's going to use a completely different technology. So when Microsoft support open row set on SQL pools, I'm like, yep, I'm going to see if this can do it any better, right? And I can change all of my extracts to do a different way, right? So here, see, this is now doing a polybase, and I can set that back. Now, so that's an example of what we call extensibility. Now, orchestration then, that's only one file. I want to do lots of files. So what I do is the metadata table has all the files, and then I can do this via ADF. We have what we call a controller worker design pattern. I think it's an industry standard, or a master slave, a few people have called it. But I think for politically correctness, that kind of wording has changed now, right? So I call it a controller worker design pattern nowadays. And what you're going to do is you'll have your FAT in terms of instrumentation. You'll create a queue of work by calling a stored procedure that gets all the metadata, all its columns. And then you'll have a way to loop over the queue of work, calling a worker on a different thread, which obviously ADF will do automatically. Okay? And then your worker will execute that. So I could run this package. In fact, I'm just going to run that. And then while that's running, trigger now, I could say, bring in all of my dimensions. And my ADF pipeline is now doing that. There's a question from the folks online. Fire away.
From the States.
Yeah.
Arizona. Am I guessing that you make decisions for reasons other than being trendy? Which solution performs better, copy into or polybase?
So the question is, how am I making the decisions on whether to use copy into or polybase other than being trendy? So the answer is, my first attempt is based on what is trendy, and then I benchmark all the different flavors, and I pick the one which performs best, yeah. So it's all based on performance at the end of the day. Because it's automated, it doesn't matter on the complexity, because the kind of stored procedure is going to be generating all the code. So yeah, absolutely. Performance is the number one factor that I use, right? So this has run an extract controller, and in a short period of time, it's hopefully extracted all of my data. Now, I can choose to also, if you saw that controller worker design pattern, I can actually write that same design pattern in a stored procedure. So I actually don't even need ADF, right? To show you an example of a controller stored procedure. If you think about the ADF design pattern, a bit of truncating and then queuing the work and then a for loop. So here we have a stored procedure, queuing the work by creating a temporary table, then truncating the staging area, instrumentation, and the equivalent of a for loop. It's the same thing, right? So there's no difference between orchestration and ADF. Now, actually, there is a difference, because stored procedures are single-threaded and ADF is multi-threaded. So for production purposes, we usually use ADF. But actually, in development, we always use the SQL one, because ADF has really slow queuing, and waiting 10 or 15 seconds for my stored procedure to run, I'm impatient. So I actually use a TSQL orchestration engine, but I maintain both orchestration engines so I can switch between them. So that's an example of a TSQL orchestration engine. Now I'll show you the TSQL orchestration engine running, just so you can see that it's generating the code, but I'll just do it for transactions. I won't do it for all the dimensions, because they're already loaded. Now so that's how we automate the extract phase. And I probably spent too long on that, because that's the boring stuff, right? I hope that most people would have extracted it. So you can see here, here's all my transactions. It has done a copy into. Oh, one common question that comes up, actually, I'll preempt, I'll answer my own question, right, is why go to the trouble of writing a stored procedure to do polybase and all that stuff when you could just tick the tick box here? Why not do that? Right? Well, there's two reasons, right? One, yes, this will write very similar code, and there's nothing wrong with that. Architecturally, I don't like to build a wrapper on top of a wrapper on top of a wrapper, right? Because what happens is the core product releases features, and the first guy who builds the wrapper doesn't include all the features, right? So as an example, there's stuff that copy into and polybase does that ADF is a year or so behind. Specifically, you can't inject a calculated column into a copy into a polybase in ADF. But you can if you write your own code, right? So tighter control of the TSQL that's kind of generated led me to forsake. Now, I'm still using ADF, but I'm not getting ADF to write my code. I'm just writing it myself, right? But in our framework, you could say, I want to use a bulk insert. And then it wouldn't use our stored procedure at all. It would use the native bulk insert. Actually, there's a switch in our framework. If we tell it that we want to infer the schema, but we don't give it the schema, and we drop the table, and we tell it to do a copy into, which up until recently was physically impossible, so it's never going to work, it's clever enough to switch it to say, well, I'm going to make you do a bulk insert on your first try, and then it will get the kind of schema, and then on the second attempt, it will switch to a copy into. So you can do smart kind of defaults in your kind of metadata to guide the system towards the appropriate way of working. Now, let's talk about, so that's orchestration, I think, right? Loading, right? So on your loading, let's just check all my data is staged, right? Because if it's not staged, I'm going to have a lot of difficulty loading, right? Exactly the same as extracts. Yeah, so here's all my data staged, happy days, right? I have metadata for my transform and load, right? And what I do is for every table, now, I named this wrong. I called it EDW tables because I soft-coded the bus matrix to create one row for every kind of table, for every dimension and every fact. I realized I should have called it transforms because sometimes you have a multi-step process in your load. So So the making of a dimension could be 2 or 3 steps. It might not be a single step. So I didn't name that appropriately, right? Anyway, I create one table that describes the metadata for the transform and loads. And I'll show you what this looks like if we go to EDW tables, which I should have called EDW transforms. You say, I'm going to tell it what the proper star schema name is. I'm going to tell it if it's a dimension or a fact. And I'm going to tell it where to get the semantic layer from, right? And that's generally going to be a view, a stored proc, or a custom pipeline in ADF. Or it could be a notebook, right, if you're doing a real external type of Databricks thing, right? And then I give it a little bit more information like, what are the business keys? Is there a primary key? And then generally a metadata table of lots of flags to turn on or off special behavior. Do I want to pre-stage the table? Have I a special proc to run before it loads or after it loads in terms of custom validation, custom inferring? Do I want to automatically infer? Do I want to dedupe? You know, these types of things to bolt on extra parts of TSQL to be generated, right? And then once I get that, to do the basic transform, at the very basic level, we create a view, right? So on top of the staging, slap a view, and the views, oh God, that's not very clear because of the, yeah, that's probably better. The view's then going to have your naming, casting, conforming, joining, grouping. I've got a slide somewhere that's got 50 different types of transforms that you might do in a view, right? So basic transforms that can be done on a row set as it's spooling through, right? So you can do a lot of stuff in a view, right? Now, obviously it reaches a level of complexity. For example, on my last customer, I had to calculate the price variance on cheese. It took me 3 months to write a series of 30 stored procedures that took 40 minutes to calculate this kind of value. I'm not going to put that in a view, right? I'm going to have to put it in a series of stored procs, right? But at the basic level, a lot of your star schema can be put in a view. The next level up is what we call a multi-step view, where I'm going to create this table, and then I'm going to create this table, and then I'm going to create this table. And the ultimate complexity is I'm going to create an ecosystem of stored procs, each of which has kind of multi-step values in it. With those 3 design patterns, as far as we're concerned, all complexities in an EDW can be handled. So this is then building this gives us enough information to build the star schema, right? So when we call this stored procedure here, table load, it's going to do the transform and the load. And the key point is agility, right? We no longer create the physical schema, right? There's no developer typing create table dim blah, create table fact. The framework will create it itself, right? And the way, and a few people ask, well, how does it know how to create it? Well, if you look at the view has the internal sys columns that tell it exactly what the target columns are in terms of the semantic model, their data type, their nullability, and all of the stuff that you need to automatically create it. So for our star schemas, they create themselves, and that's +1 point on, well, or -1 point on agility because you want the kind of lowest score, right? But if you have to physically create it, it means you've now got to go through a release process and then have that and an extra thing for the developer to do. So we take that away from them. Developers no longer have to create tables in the star schema, right? So when I've loaded it, you can see that what it's generated then is this has created the table, and obviously because it's a SQL pool, it's got to have some assumptions about how it's going to be generated, right? And there's a way in the metadata of overriding this. So especially because this is created it's created a replicated table, and in terms of structure, it's on a heap. Well, you might want it on, it could be a very large dimension. You might not want it replicated. It could be fast changing, right? You might want to have it on a hash thing. So from a tuning, you come back to tweak all the metadata, and then it automatically changes to do the tuning part of the process. So that's an example of a table load, and the framework automatically does stuff then, like, because we told it what all the business keys were, it can now add, well, I would say a unique index on the business keys. You'll see it's called a UX. That's only because on our on-premise ones, it does actually create a unique index. But obviously, SQL pool doesn't support a unique index, so it just creates an index, right? And this means that when you're doing surrogation or looking up all of your business keys, you've got a slightly faster query. So we standardize the indexing so that the metadata also creates any needed indexes as standard. Now, within the stored proc that generates all the metadata then, you can develop it so that it's smart, so that if you run it a second time, well, the table's already there. And a dimension, you probably don't want to drop it and recreate it every time because it's got keys to the fact table, right? So it can recognize that it's there, and you could then dynamically generate your upsert, right? Either by a, yeah. So this is doing upsert as a separate operation. Obviously, I'm just on a new customer. I'm literally putting in a merge column to have a crack to see if we do a merge operation instead of an insert of an update, will it go any faster, right? It probably will, right? Because a double scan over the kind of data is avoided, right? So that's an example of that. And obviously, the framework can then have logging and lineage and stuff like that, so that the developer is only doing the metadata. The login and lineage automatically happens, so I can have these sort of tables that say, well, a load started here, this is what was loaded. And from a lineage point of view, the dimension that's loaded would have this lineage key on it that uniquely tracks it back to a log table to have the name of the file and where it came from and everything else. Not to be confused with schema lineage, i.e. sort of purview, because I know that's quite sort of hot at the moment, right? Now that's only a so that's some of the metadata, right? And then going up the stages to orchestration, what if I wanted to load loads of dimensions at once? Well, obviously you do. Well, then you're into your controller worker design pattern. So I've got an extract controller and a load controller and a load worker. And actually, most of our projects also have an ingest controller, because usually we've got to bring all the sort of data in. It depends. Some of our environments have, they're basically sort of pushed into Azure. So one of our big SAP customers has a third-party tool that actually pushes it into Azure. Others, we have to grab the files. I'm just talking to one customer who all their data is on an SFTP, and we've got to pull it over there and sort of drop it in. So it's all the same architecture, though. The controller queues the work, loops over the work, and then the worker has some dynamic way of understanding what type of work do I want to call, and call in the appropriate artifact, be that a pipeline or a stored procedure or a Databricks notebook, right? It doesn't really matter. The kind of principle is the same. So let's run. Now, I'm going to load the TSQL load controller, but actually, this would do the exact same as running the ADF load controller, right? If you look at the stored proc, it's doing the exact same thing. It's just all within the SQL pool. And it's going to load all of the dimensions, right? Now, obviously, as I mentioned, one of the limitations if you write a controller in a SQL pool, one of the nice things is there's no more ADF. One of the nasty things, though, we haven't yet got a good way of making stored procs in SQL pools multi-threaded. So on the on-premise, there's some clever stuff that you can do with sort of SQL CLR and stuff like that by launching different threads. Getting an asynchronous call within a pool without using something external is quite hard. If anyone has found a way, if you drop us a line on kind of Twitter. So here's all of the dimensions loaded, all with conformance. We now have standardization on how the indexing is done, how the table structures are stored, because it's generated from metadata. It's not a developer actually or a DBA actually doing that, right? Now, dimensions are, I won't say they're easy, right? Because if you talk about something like a customer or a product, on our projects, they usually come from lots of entities, right? So the view that is the product could be fairly complex, right? It could have lots and lots of stuff joined. So the sort of business part of the view of creating a dimension is very complex. But the mechanics of taking that view and putting it into the data warehouse is generally quite simple, because once you have that view, the columns of the dimension are the same, right? So it's literally a select into, right? And then updating it is just a merge operation, you know, insert, update, merge statement, however you sort of generate, it's very straightforward. Now, facts are a little bit more interesting, right? Because with facts, if you treat a fact like a dimension, if I just call the fact load, I've created a view for the finance, right? Which is the transactions table of the general ledger, right? And when I run this, it will create, now it's actually used a CTAS because it doesn't have a calculate column, I suppose. And you see, it's got a bit more clever defaults. It kind of knows it's a fact table, so it's like I'm going to, by default, I'm going to put a clustered column store in there. It's put it as round robin because in the metadata, it's just got a null on the table distribution. Obviously, we can override that if we have some tuning. We always put all our fact tables as round robin as version 1 because we don't know any better, right? And then we look at the query plans to see if we want to upgrade them, right? But the key thing is when we upgrade them, all we're doing is changing metadata, and the sort of TSQL generated will reflect that. Now, the problem with this is if you look at the fact table that's generated, it's got all the business keys. It says here, which is fine if you're only using natural keys, right, and you don't have a single surrogate key, well, that's happy days, right? Now, you've usually got to have a surrogate key because some of your dimensions of stuff like compound keys, you know, you're not going to have a good natural key unless you've got tables that are ISO standard, like, you know, countries or something like that, right? So how do you deal with surrogation? Because your TSQL generated is more complex. So what we do is we soft code the bus matrix. If you think about a bus matrix, everybody recognizes this as a Kimberley bus matrix. Sorry, I'll zoom in. It's not quite as... So you have your facts, so your measure groups, and your blue. Kimball always does his bus matrix the other way around. I always do it this way around, and anyone who recognizes all the colors will give me a head nod to the old kind of MOLAP days, because that's how the sort of join editor was in analysis services. Anyway, those X's say what dimensions link onto what facts. So to soft code your matrix, your bus matrix, all you've really got to do, we know all the tables, because that's kind of my EDW tables. I've just got to say what tables join to what other tables. And then the model of the metadata knows my bus matrix, right? So that's effectively a many-to-many join, right? So all I've got to do to soft code that is create a many-to-many join. So I do this here. So this table here, EDW table joins, specifies how the tables join back to themselves, which is basically how the facts link to the dimensions. And when I do that and redo a load, and I should have really done this, you'll see it automatically generates the surrogation. See this? Now, unfortunately, Data Studio doesn't put the carriage returns very well. It actually comes out as nicely formatted code. But what you'll see is for each dimension that has to be surrogated, it puts an inner or a left join, depending on there's a flag. You know, is it dirty or not dirty, right? Automatically generates all the surrogation code so that the end result is more like what you'd expect to see in a cleaner star schema with kind of surrogate keys, right? Now let's, that's that. And the last thing to talk about is orchestration, right? Making it all work, right? Yeah? Yes, early arriving facts. So the question is how you arrive for early arriving facts, yeah? So that's what we basically call a dimension inferral, right? So what we do for that is we've two ways of doing that, right? One, in the dimension, if it's a small system, we might have a union all on to an inferral piece of TSQL. Two, we actually have a piece of metadata where we tick inferral and then put the column, and it dynamically generates the code to do the inserts into the dimension. Three, and this is very common, in the metadata, we say the framework does this. Before you do the load, run a special stored procedure. And in that special stored procedure, you can put bespoke code, nasty validations. You might say, well, before I load it, does the sum of this equal the sum of this divided by 10 over 2, right? You know, that sort of bespoke code that you don't want to write an automation framework for. So we use those three techniques for inferals, and, you know, you can use either of them. But it is, yeah, it is a complexity that you've got to deal with, right? Orchestration, then. This is what bad orchestration looks like, right? Because it's hard-coded, and when a new thing is added, someone's got to update that master package, right? -1 point agility. So we soft code the orchestration by creating a table. And on the, now the way that I do it is on the table, I specify, oh, that's my aunt calling me for a 1-hour chat. No, a load group. And it's just a number to say, this is the logical sequence of loading. Because you might have a snowflake where a dimension has got to be loaded before another dimension, or all your dimensions got to be loaded before a fact, or a fact table could be an aggregate where it's got to be loaded after another fact table, right? So we specify a load group, and the controller does everything in load 0, then everything in group 1, and then everything in group 2. And by that, we can dynamically change or add entities without having to change any code. Dynamic orchestration as opposed to fixed orchestration, right? So that's a key concept that we try and get to avoid what we call fixed orchestration. And then on the load controller, we can say load, and it now knows the sequence by saying, do everything in group 0. Now, obviously, there is a bit of shuffling happens. So what happens is you start off at 0, 1, 2, and someone adds a table that has to be done between 1 and 2. And then everything after 2 has got to be shuffled down if you're unlucky, right? So you could start off as a number between 1 and 100 and go up in tens. There's lots of ways of doing it. But that's how we do soft-coded orchestration. So I'm almost out of time. So I wanted to, I wrote a blog post on a maturity model. If you're doing automation, I define 6 levels of automation that you could be at, right? Level 0 is what I call a bunch of monkeys, right? So that's where you just set all of the developers out and you go, well, you develop that and you develop that, and there's no common, framework. A level 1 is where the architect actually gives them a template, and he says, hey, use this kind of template, right? Now, that's not good for agility or extensibility, because they copy that template hundreds of times, and it becomes hard to change, right? So the action really starts at level 2, some sort of parameterized template that's reused so there's a smaller code base. And then level 3 is introducing metadata and some of the enterprise features. And level 4 is then taking that automation and putting it into a separate IP, so it's not glued into the solution. And many partners have just about got that level 4 because they have multiple customers. So they can't leave all the IP in one sort of customer, right? Now, level 5 and 6, you're talking about product companies to really go to that kind of level, right? But you could go as far as you want to, right? There's some links here. Everything I've shown you, there is a public Git library. Well, it's on Azure kind of DevOps that gives you instructions on how to download a sample database, how to clone the repository, and stuff like that. So this link here will give you that. And if you Google Bob Duffy EDW automation, you'll hopefully find some of my blogs, right? But that entire project I've done. Now, this is not a production automation framework. This is sample code. I don't want anyone saying, I've used your framework, how much is it? It's free, and it won't work in your production. You have to use it as a learning guide to write your own stuff. Thank you very much. Would love for some feedback if you like the session. Obviously, it's only 50 minutes. Please do let me know. And I will leave that up there. Thank you very much. Thanks.